go that way. There, that's better. So, we had seen our first example of a C program, compiled, executed, etc. So, I have basically said all of this stuff on the summary slide, so I'm going to whip through it pretty quickly. So, once the compiler is invoked, it goes through a certain number of stages. First up is pre-processing. The purpose of pre-processing is to make the code ready for parsing and generation. We remove comments, we expand macros, and we expand any code included into the program using include statements. So in this sense, when we include standard I/O, that's actually pulling code out of a file in the operating system, inserting it before the code that we have written in our file, and then processing it from there. After pre-processing, we parse the file. This generates the abstract syntax tree by breaking the code down into tokens. Parsing is also known as tokenizing. Once we have an abstract syntax tree, we assemble it into a series of machine code or object code instructions. Optionally, we can save the object code to a .o file. We'll see how to do this a little later on in the semester. After that, the object file is linked up with the relevant libraries and an executable is produced. Again, I had a question about this after class, so I want to reiterate this very, very clearly, right? A C program, once compiled, does not require any exterior environment to run other than the operating system. The code doesn't, like, if you're using Visual Studio, you may be forgiven for thinking that code executes inside of Visual Studio, right? And that Visual Studio is the thing that runs code. This is not the case. When you're writing a C program, the executable that's produced is runnable directly by the operating system, right? There's no program sitting between the executable and the operating system itself, right? This is in contrast to languages like Java and Python, where the interpreter needs to sit between the program and the operating system. So a C program, once produced, is the same level of privilege, shall we say, as a solitaire program, your word processor, the C compiler itself. All of these are just executable programs. When you produce a C file and when you compile that C file to an executable, it is also just an executable file, right? And you can just execute it. You don't require any additional you don't require anything additional to run it. Does that make sense? Awesome. Good. So, in case you're a visual type of person, here's the same thing stated but with pictures and much smaller font. Your invocation of GCC may not end successfully if your code has bugs in it. It depends on the bug. It depends on the severity and the placement. The most likely thing that you will encounter the first time that you try to compile a C program is a syntax error. Programming languages are defined by a set of syntax combined with a set of semantics. These are very important words that you'll hear me use a lot. Syntax and semantics. Syntax is how it says it. Semantics is what it means. Different languages can have different syntax but the same semantics, especially if they are highly related languages. So, syntax basically means grammar. in the same way that the English language and many other languages have particular forms by which sentences must be constructed. There are rules for using prepositions and commas and all of these types of things. The set of rules that dictate how English is put together is the syntax of English. In the same way, the rules that govern how a programming language is put together are the rules of syntax of programming languages. So when you have a syntax error, normally it's pretty easy to fix, because all you have to do is find the character that you've misplaced and fix it. Incidentally, if you submit code with syntax errors, it's not going to get any marks. Basically, from my perspective and our perspective as a grade team, if you can't even be bothered to compile your code before submitting it and make sure that there are no syntax errors, it's basically insulting to us that you've even submitted it. You might as well have submitted nothing. That's the perspective we take on syntax errors. So make sure that you fix them before you submit anything, because otherwise you won't get any grades. So, anyway, forgetting a semicolon, for example, is a syntax error in C. Semicolons will take a little bit of getting used to for you guys. Every line needs a semicolon at the end of it. This is just a thing you're going to have to memorize. So in addition to syntax errors, we also have compiler warnings. Now this might be a more new concept to you, as Python doesn't really do this. Warnings do not halt the execution of the compiler, as errors will, but they will indicate problems with your code. These warnings indicate things that will not prevent an executable from being produced. However, they are hints that maybe your code doesn't do what you think it does. Some warnings are not shown by default. If you invoke the WALL flag, that's warnings all, in GCC, that tells GCC, I would like to see all of the warnings, please, even the obscure ones. Recommended. If you don't want to see any warnings at all, which is not recommended, use the lowercase w flag. You may be warned about using data types and pointers incorrectly, not using variables that have been declared, and using a single equal sign instead of a double equal sign. These types of common errors. Does that make sense? Question?
What does using a flag mean?
What does using a what?
A flag mean?
Oh, so when you provide options to a command line invocation that starts with a dash and then a series of characters, these are known as flags. So this is a flag, that's a flag. This is a flag. This is a flag that indicates what the name of the output should be. Does that make sense? Cool. Any other questions? Yes, sir.
What do you mean by using equal and double?
So a single equal sign indicates assignment, right? You're setting the value of a variable. A double equal sign indicates a test of equality and is a Boolean operator. It returns either a true or a false. Or, like in most languages that are higher level languages, they will prevent you from performing assignment inside of an if statement, right? It'll just be an error. In C, for various arcane reasons, you can actually perform their assignment operations inside of loop conditionals and if conditionals if you mess it up in a particular way. It will not prevent you from doing that, but it will warn you in case that's not what you meant to do. This is again sort of the design philosophy of C. It's like, oh, you want to do that? Okay, I'll do that for you. I mean, I don't think it's a good idea, but I'll let you do it. That's C. C is a very laissez-faire language. Any other questions? These have been very, very good questions so far. Really, like, if you have a question, ask it, because there's probably at least, 20% of the rest of the room that has the same question at any given time. So, right. So, in Linux-like environments, an executable is run using the following command: // and then the name of the executable. If you're in a hated GUI environment, you run an executable typically by double-clicking on it. Once invoked, the C program is loaded into the system's primary memory, normally RAM, and then executed. The CPU runs the program starting with the first instruction and proceeding until the program terminates. Any questions? Good. Again, if you want some, okay, there's one point that I'll talk about here. So, as you go on through your journey of discovering what the heck a processor even is, you will learn that there is a distinction between data memory and program memory. The variables and data structures and all of the data that's used by a program is stored in data memory. This is typically kept separate from program memory. The instructions that comprise the program itself are stored in program memory. Right? So, often your code will contain bugs despite being compiled and linked successfully. In fact, the majority, I would say, of the bugs that you deal with on a daily basis will likely be of this category. Semantic errors rather than syntax errors. You have misplaced some concept rather than having misplaced a semicolon, right? Many semantic errors are due to a less than thorough understanding of the language in which you are operating, but a lot of semantic errors are also attributable to the fact that it's just difficult to write programs, right? It's difficult to keep all of the state in your head all at once. It's difficult to create a series of instructions. The difficulty of programming results in semantic errors. Some semantic errors will just straight up crash your program. These are known as fatal errors. Was it something I said? Dividing by 0 is a fatal error. It'll crash your program outright. Trying to access memory that doesn't belong to you is also a fatal error that will kill your program right on the spot. The operating system immediately grabs it by the scruff of the neck and takes it out behind the woodshed and shoots it in the face. This is known as a segmentation fault. Other types of errors, non-fatal errors, normally cause a mismatch between the expected output of a program and what it actually outputs. So this is what you would consider your program, works most of the time, but if you give it this specific case, then it doesn't give you what you expect, right? That is also a type of semantic error, but it is a non-fatal semantic error. So your program will run, it'll just produce the wrong output. Yes?
What do you mean by memory doesn't belong?
When we get into pointers, it'll be a lot more clear. But, so, very quickly, right? One of the major topics in this course is pointers. Pointers are memory addresses which you manipulate as you manipulate other data. One of the operations you can perform over pointers is to follow the pointer, the memory address indicated by the pointer, to whatever memory it corresponds to in system memory. The operating system draws a box around the memory that you're allowed to touch. If you try to step out of that box by dereferencing a pointer whose address falls outside of the series of addresses the operating system has assigned to you, the operating system kills your process. Because that's how viruses work a lot of the time. Any other questions? Yes?
Will a fatal error tell you what's wrong, or would it just crash and then you have to figure it out yourself?
Most of the time it won't tell you what's wrong. It depends on the class of error. A segmentation fault will tell you it's a segmentation fault. It really depends on the specific error that you get. This is not a situation like Python where you get a bunch of different exceptions that tell you like information about the particular type of error you get. C does not have exceptions, and it does not have exception handling. These are features that do not exist in C. Does that make sense? Any other questions? Okay. So, running a program with specific inputs and looking for a known correct output is known as testing. If you do not test your assignment submissions thoroughly, you'll probably be disappointed with your grade as well. Testing, by the way, is a sufficiently complicated topic that you can build a very lucrative career just by knowing how to properly test programs. There are many very, satisfactory careers in software and hardware testing, specifically. Quality assurance, my friends, quality assurance. So, if we wish to interact with a C program using a monitor and keyboard, that C program needs to interact with the following: standard input, standard output, standard error. These are the mechanisms by which your program acquires input, produces output, at least so insofar as it's outputting, characters into a terminal or something like a terminal, which is what we're going to be doing most of the time. And standard error, which is kind of like standard output, but specifically and only for error messages. So, when you press buttons on your keyboard, your keystrokes are logged in a file, standard input. When your C program is waiting for input from the user, it waits until an enter keystroke has been logged in standard input, then it collects up the contents of standard input and uses it. You can actually buffer way more commands in standard input than than just the current one it's waiting for. But that's kind of an issue for a different time. Standard output is kind of the same process in reverse. When your program prints something, it's placing characters into standard output. Periodically, the operating system processes themselves collect the contents of standard output and print them to the monitor. That is how output works. Standard error works in the same way as standard output, but it's separately maintained and specifically for error messages. Does that make sense? So, when I'm talking about standard input and standard output, I'm talking about buffers, right? Places where characters are stored. All three of these streams are either emulated or connected in more complex environments, such as Jupyter and VS Code. When I am operating in just flat Linux, I am actually interacting with my system's own standard input and output in a direct manner. If you're using VS Code, it's creating a sandbox environment where it's spoofing standard input and output without, interacting with the system's real standard input and output. Right? Make sense? Any questions? Okay, well that's the introduction done. I've had this exact conversation with my wife. Good. It's a mark of your nerd status how far you can carry a conversation like that. So, good. So, now that we have some idea what a C program is, how it can work from sort of an exterior level, let's dive a little bit more into language semantics themselves.
I have a question about Linux. When you're using Linux, do you use Ubuntu?
I'm using Mint, but it's Ubuntu derived. Arch is for hipsters.
So when you code C on Linux, you code it on Ubuntu, or Ubuntu is used to access Linux?
So what Linux is, really is the Linux kernel. There's a number of Linux distributions which all share a common code base for the deep level operating system functions. There's a large number of different varieties of Linux. You know, you have Fedora, you have Red Hat, you have the Ubuntu family, which is actually Debian derived, you have Arch Linux, you have Gentoo. Like there's a whole family of Linux distributions. Each one does slightly different things in slightly different ways and is like a matter of like personal preference for the person who installed the operating system. Some Linux distributions are designed specifically for very old computers and have very minimal operating system requirements. You know, some are designed for ease of user interface and that sort of thing. It really, you know, so when I run a program, the interface that I'm using is primarily been set up as Linux Mint, right? But the C standard library that I'm interacting with is part of the Linux kernel, and that is standard across all Linux distributions. Does that make sense?
So on Mint, it's connected to the Linux operating system?
Well, Mint is itself an operating system. The Linux kernel. The kernel is underneath the operating system, right?
And when you start the code, you just like write the code on a text file and use it on Linux, or do you code directly on Linux by opening a text file?
So I'm using Linux's installed programs to create plain text files containing C code. I am then using the C compiler, which is also packaged with Linux, to compile those to executables, which I then execute also within the Linux operating system. But many of the functions that are used, such as printf, you would consider part of the kernel. Does that make sense?
Yeah, and it uses like a new compiler and one.
Yeah, it uses GCC. Yeah. Any other questions? Okie dokie. If you did have your hand raised at any point and I failed to see you, just throw something at me or shout at me or something, okay? Okay, so now that we know what C is, let's learn how to program it. This set of slides assumes that you have a reasonable familiarity with Python. We'll use Python as a jumping off point to examine how C does things and how C does things differently. What things exist in C that don't exist in Python and vice versa, right? So, we've already seen the Hello World program, right? So this is the simplest C program. Versus the last time we saw this, you'll notice we have the void keyword inside of the parentheses. Doesn't have to be there, but it just indicates that main doesn't take any arguments, right? The green stuff here is comments. The opening for a single line comment in C is your 2 slashes, 2 forward slashes, Anything past that point in the line is comment. Here's a very, very important point that we'll see a number of times. In Python, you can use either single or double quotes to indicate a string. This is not the case in C. In C, double quotes always indicate a string. Single quotes always only indicate one single character. Python likes to pretend that there's no such thing as a single character, but characters are a native data type in C in the same way that integers are. So you can declare a character variable. Strings in C are properly thought of as character arrays. Right? So I won't bother executing this one because we kind of already have. Does anybody have any comments or observations on this little tiny piece of code before we move on? Yes?
Why do you have to use a new line character if it's only one line?
Why do you have to use a new... Unlike Python, thank you, I'm very glad that you brought that up. So Python's print function automatically inserts a new line at the end of every print statement. C's does not. Printf does not insert a new line character at the end of a line, so you have to put it in manually. We actually have some slides on this coming up. Any other questions? Yes?
What does studio.h mean?
stdio.h, that's standard input and output.h, is the C library that contains the definitions for functions for interacting with standard input, standard output, standard error, as well as files in the in the file system. So without this line, printf is an undefined function that will cause this program to not work. Does that make sense? Any other questions? Yes? That's C++. Yeah, it has to be stdio because this is C, not C++. Any other questions? You, sir, with the headphones. Or no, you just have a big collar on. Yeah, okay.
Instead of intermediate, can it be like boolean or star something like that?
Surprisingly, that's actually like more close to truth than you might think. Yeah, so basically when the program ends, what's getting passed back to the operating system gets cast into an integer anyway. So if you want to return like a boolean or a character or something, you can, but why would you? Right? There's going to be a lot of that in C. You can, but why would you? Right? We're going to have slides on that very shortly. Yes? Return 0 is implicit. So if a function reaches the end without having hit a return statement, return 0 is inserted automatically. It's actually, in technical point of fact, you can leave off the declaration of the return type of main, and it will put integer in by default as well. But good practice generally dictates that you put int in there. A lot of the C code that you're going to see, so to speak, is convention, not strictly required by the compiler. Yes?
If I declared that as like a boolean or a char, that concept models, is it an integer?
Not necessarily. It would probably still compile. You could probably get away with it. The question is, if you're returning a character, that's a non-zero exit status unless you're returning a null character. So, also it's not the right number of bits, but probably it would be fit into a slot the size of the current number of bits. Does that make sense? Yeah. Cool. Yes.
Why do we include semicolons in like the second, fifth, and seventh?
The purpose of the semicolon? All statements are terminated by semicolons, period. Exclamation mark. That's just C. It's also most sane languages.
So include isn't a statement? Like what?
No, technically it's a preprocessor directive. It's not an assignment statement or anything like that. Any other questions? Yes, sir.
Is the type of main function required to be in or in other apps?
I've already answered that question twice.
Sorry.
Watch the video back. So, in Python, the octothorpe character designates a single line comment, and yes, that's what it's called, octothorpe. In C, 2 forward slashes are used. C also has multi-line comments. You begin with forward slash star, you end a multi-line comment with star forward slash. Anything between those two sets of characters is a comment. These stars are for decoration. They are not required to be there. Multi-line comments are a thing that kind of exists in Python, but not really. In Python, this is roughly equivalent to the idea of a doc string. Doc strings, of course, can only appear in particular places in the file, whereas a multi-line comment may occur anywhere inside of a C source file, including in the middle of a line. So you can start a comment in a line and end the comment in the same line, and that allows you to do, code on either side of them. Does that make sense? How often do we comment things?
All the time.
Thank you. Comment your code or else! So, here are some guidelines for commenting code in C. At the top of your file, indicate author, date program was created, date program was last modified. Indicate the purpose of your program. Comment each function to indicate what the purpose is. This includes any assumptions about the inputs, properties of the outputs, and invariants that will hold throughout execution. It's also useful to, on the last line of a function, put a comment like end of function X. The thing about C functions that's probably going to be new for you is that a C function can be quite long and occupy many screens in whatever editor you're using. So it's useful to know which function you're looking at the end of. So it's, you can just sort of put a comment in there, and it's helpful for navigating your code. So yeah. Good. So, let's talk about preprocessor directives. In Python, we access libraries using import. In C, we use include. Lines beginning with the octothorpe character in C are preprocessor directives. Preprocessor directives are processed before the program is compiled, or parsed, pardon me. .h files are known as header files. Many of C's most important libraries are referenced by header files. So a header file will typically contain the definitions of functions which have been pre-compiled for your use and located elsewhere in the operating system. So, when you use printf, it's not recompiling printf each time. It's making reference to an executable that contains the definition of printf, and it's loading the executable code for printf, but the way that it knows how to do that is that you're loading the header file. So, any questions about that? Basically, it's just this is how libraries actually work, stdio.h contains the definition for printf and much more besides. Adding the line include stdio.h to the beginning of each C program that you write should become reflexive. As soon as you open a C file, you should just write that line because there's basically no C program that you'll ever write that doesn't meet it, right? Other languages would do something like include that in the prelude, which is the set of functions which are loaded by default when you start up Python, for example. C doesn't really have a prelude. Anything that you want, you have to import manually. And that is the story of C programming in general. So, In Python, white space is used to describe used to determine program structure. What I mean when I say white space: space characters, tab characters, new line characters. White space is any character that doesn't show up as a character, basically. C uses special characters instead of spaces, tabs, and new lines to determine when statements start and stop. So in Python, because lines are not semicolon terminated, you can only have one statement per line in the file. In C, you can have as many statements per line in the file as you want. Well, technically speaking, in Python, you can use the semicolon as an operator to put more than one on a line, but it's not the same thing. So, each statement in C, so long as it is a statement, must have a semicolon terminating it. This is a very frequent type of error. Basically, what happens with the C compiler, if you forget this thing, is that it thinks that you just wanted to keep the statement going, and it considers, like, if you had x equals 3, y equals 7 with no semicolon here, it would think that you were trying to perform two assignment operations in one line, and you were writing 3, 7 with no operator in between them, and that's a lot of syntax errors. Typically, a missed semicolon will be indicated as being on the line, like the error it gives you indicates the line after the line that missed the semicolon, right? That's just one of those little things. So, in Python, statement blocks are indicated using the colon and indentation. So this is a quick little Python function for calculating the max of two numbers. In C, statement blocks are indicated using open and closed curly braces. You can see that, so to speak, each of the points where we have a colon in Python, we are opening a curly brace. In C, the statement block opened is closed by a curly brace, right? You can see the structure. So in C, this is a convention. The indentation levels for if statements and loops and all the rest of it are a convention. It's not required by the compiler. You can actually do anything you want with this white space. White space doesn't matter in C. It's not given any semantic content. So what they did when they invented Python was they took the conventional way of writing a C program that wasn't enforced by the compiler, and they enforced it by the interpreter, right? And that's how they got rid of the curly braces, which, again, most sane languages have. Generally speaking, I think it's like just bad policy to have characters that don't even show up in the display carrying program code in, That's my policy, but, be that as it may. Do you guys get the impression that I don't like Python yet? So, this C program, right? Pretty simple little C program, is precisely and exactly the same as this C program. They are the same program as considered by the C compiler. Now, one of those is preferable, but they're both equivalent, right? Basically, if you took all of the white space and removed it, and all of the comments and removed it, and you did that with both of them, you would get the same program exactly to the character. So, again, C is a language where many things are possible which are not advisable, right? You can write your assignment like this. Is it advisable to write your assignment like this? Absolutely not. Right? Question?
So whenever you set a variable to Boolean, you always have to state for that variable.
Yeah, actually, I'm technically making a mistake here. I should be including standard Boolean, the standard Boolean library. So, first of all, C doesn't have Booleans unless you import the Boolean library. Second of all, when you use a variable, the type of that variable must be declared. Whether it's a Boolean, whether it's an integer, whether it's a character, whether it's an array, all data types must be declared on the first use of that variable. This is a huge difference with Python, which just lets you, put them in, right? This is actually a much better way of going about it. Follow-up question?
Yeah, I just said, so like, when you say the first use of that variable, so if you were reassigning that variable in a different function, you would have to state it as, say, the integer, and have to rewrite it.
If you were using a variable of the same name in a different function, unless that's a global variable, those are two different variables. So those are two different local instances of a variable with the same name. So you should think of them as separate. But yes, the type information must be declared in both cases. Cool. Don't use global variables. Question? I'll come back to you.
If you were to run like this code as is through a compiler, would you get the warning because one of the lines doesn't have a semicolon after it? Or is that sort of
Which line doesn't have a semicolon after it?
why?
Oh, that's because it's continued on the next line.
Yeah, but you get the warning because of that.
No.
So then how does the compiler know what a line is?
Semicolon.
Well, how does it give a warning that they don't have a semicolon?
It doesn't. It gives an error. If you forget the semicolon, it's because the next line will run into this one, and that'll be a syntax error of a different type. Right? It doesn't ever directly tell you missed a semicolon.
I got warnings.
Cool. Yes. That's the return type of the main function. It means that an integer is returned to the operating system when this program finishes. Yes?
So I noticed on some of our assignments we're given libraries included already in files. Are we allowed to include other libraries that we want to use?
Yes. Especially the C standard, anything in the C standard library is up for grabs. Question?
What would happen if we didn't include the int before x equals 17?
It would be an error. It would be, so if you left off the int here, it would say assignment to undeclared variable or something like that. So you can't assign to it until it exists. You bring it into existence by giving it a type. Make sense? Any other questions? Wow, this is I really wish we were picking apart this code on a different slide where the code actually makes some sense. Question?
Does it matter what line you start with?
No, technically, so long as it follows the correct statements and there's nothing in between. Right? You can, okay. There's some debate in the software community as to whether the opening curly brace should be on the same line or the next line. Same line, these are the people who are defenders of truth and right. People who put it on the next line are nefarious thugs. But, because it just makes the program longer for no reason. But, yeah, there's no, you can put it 10 lines down if you want to. There's no restriction, because it's C. Make sense? Yeah, okay. Thank you, everyone. If you have any questions, come to the front.